Hi again, intermediate algebra students. Time for another online lesson, continuing here now in Chapter 8 on systems of equations. If you remember, so far we've talked about solving systems by graphing, where the two lines cross and we find the intersection. We also talked about solving systems by substitution. Today now we start another algebraic method called elimination. And we have a couple parts to this. So today we talk about the easiest part, I think, and then we'll get into something more difficult tomorrow. Now, elimination has some different connotations. Mainly you hear about elimination when we have some contests like Dancing with the Stars. Some people are eliminated. When we have the baseball playoffs, sometimes you get to an elimination game, any kind of sporting event like that. I'm not quite sure what this is, something with WWE wrestling or something, but whatever, it doesn't look too promising to me. It looks kind of scary. But anyway, elimination, of course, what we're talking about is with these systems of equations. So it's just one more technique, just like the other ones we mentioned. But this is an algebraic technique, so we really don't require any graphing here. And this method, we will always try to eliminate one of the variables. In a sense, that happened when we did substitution as well, because we tried to rewrite an equation so there was only one variable. Same thing here. Now, the way we always do elimination is by adding the two equations. So we almost always like to have them in this standard form is kind of a good starting point, and most of them are. And generally what we do then is we just add variables. And what we're hoping to find out then is that one of these variables should cancel out. Now let's just take a look at this first system we have here. X plus y equals 12 and x minus y equals 2. Notice when I add columns here essentially, let's just see what happens. So in this case, x plus x, remember this is like 1x plus 1x. Of course I'm going to get 2x out of all that. Now look what happens in this second column though. When I add 1y and then negative 1y. You can think of this as a minus sign, or you can think about it as adding a negative. So 1y minus 1y, of course, is 0. And typically I don't put 0 down when I write this out. I just leave it blank so it doesn't clutter this up too much. Then I still have my equal sign, and of course 12 plus 2 is 14. So what I've just done now is eliminated one of those variables. Now the equation I have left I should be able to solve fairly easily. Just divide both sides by 2 and I see that x is going to be 7. And then there is a little bit of substitution that comes into play here, because now I have to take this 7 and put it back in place of this x. It doesn't have to be in this equation, it could be the other one. So then I have 7 plus y equals 12, and you can just figure out what that is easily enough. Y is going to equal 5. So once again, as is customary with these ordered pairs, or excuse me, with these systems of equations, your answer then will be an ordered pair. In this case, 7, 5. So that's a pretty basic example. Look at another one here, another couple actually. So now here's ones with multiple coefficients here. Let's just see what happens when we add these up. So in this case, 3x plus 3x is 6x. 2y minus 2y, or plus negative 2y, there's my 0 there again. And negative 2 plus 12 is 10. Ooh, this is not working out so nicely. Divide, I wonder if this should, if I copy this down right, this looks a little suspicious. I need to divide by 6, so x is going to be 10 over 6. And then I would substitute that in place of y to see what that was, and that might be a little messy, but sure enough that's what I would end up with. I think I must have made some mistake there because I wanted these to come out a little bit easier, but don't tell anybody. So in this case as well, you can see that one of the variables was eliminated. Let's go on to my other one here and see if I got that one any better. Now notice here in this case, when I add these up, this would give me 12x, this would give me negative 2y. That doesn't help me because I have not eliminated one of those variables. So here's now where we need to start making a little bit of variation or changes in these equations. So now you do notice that we have a 6x and a 6x. It would be nice if one of those was negative, wouldn't it? And I can do that if I multiply everything, let's say in this top equation, if I multiply everything there by -1, basically what's going to happen is that's going to turn into a -6x. This will be a -5y, and this will be a -4. And the advantage of that, of course, is now when I add up columns, -6x plus 6x is 0, -5y and -7y is -12y, and -4 and -20 is -24. This one works out a little bit nicer, and I get y equaling 2. Then I have to go back to either of those equations and substitute that for y. Maybe I'll go back to the top one. So I get 6x plus, well, 5 times 2 is going to be 10 equals 4. I'll subtract 10 from each side, so I'll get 6x equals -6. So sure enough, x equals -1. My ordered pair here then for an answer is going to be 2, -1. So there's a case where I created kind of an opposite situation, even though my original two equations did not have an opposite. Some word problems that would make use of this method as well. Here's a pretty classic one saying that the sum of two numbers is 70 and their difference is 24. Use a system of equations to find the two numbers. Now obviously you could kind of guess and check and get this fairly quickly, but we'd like to learn how to use a system of equations to solve this. Eventually we'll do some more practical problems here in helping us to figure these out as well. So the sum of two numbers, I can just use my numbers as x and y. I don't really know what those are. Sum, of course, means adding. The difference is 24. Difference, of course, means subtracting. So sure enough, there is my little system. And as you can see, we right away have this opposite situation, so I can add them up. 1x and 1x is 2x. The y's are eliminated here. 70 and 24 is 94. So I divide by 2, and I get that x is going to be 47. And to figure out what y is, then again, I just have to go back and put this in either one of the equations. I'll put it in the first one up there. So I get 47 plus y equals 70. And I subtract 47 from each side, and I get 23. So once again, my two numbers then are x equaling 47 and y equaling 23. We'll look at some more practical applications of these systems of equations later on in the week, certainly. Systems of equations look for opposites. That's the whole key. And as we go on to this tomorrow, we'll see how we can actually create opposites even when the systems don't have them originally. All right, thanks for watching, everybody, and we'll see you guys in class.